aliens,
Little green man.
1,000 eyes or one eye.
sci-fi movie monsters,
free-floating with tentacles.
Some unknown hyper-advanced civilization.
could science fiction ever become fact?
I think it's really simple why Hollywood is fascinated with the concept of first contact with aliens, because that would be probably the greatest scientific discovery in all of human history.
Problem is, our universe creates massive barriers to meeting extraterrestrials.
It's almost as if the universe is deliberately stopping us from making first contact.
We're searching the cosmos. Will we ever find intelligent alien life? Or are we alone? Arecibo Observatory, Puerto Rico. 45 years ago, it sent a powerful radio message deep into space, kickstarting our efforts to make first contact.
The Arecibo message was the first communication or attempt to communicate with a possible civilization out there in the galaxy or outside of our galaxy.
Today, that message is speeding towards the M13 galaxy cluster, 25,000 light years away. It contains information about our world, where we are, even the makeup of our DNA.
The purpose of this message was, of course, like trying to say hi, and also like to light up this question about, are we alone in the universe?
But what chances are there that an intelligent alien race is out there waiting to receive our message?
Do I think there's other intelligent life out there in the universe? The answer is a resounding yes. Yes, I do. We know that life began on Earth pretty much as soon as our planet solidified. So why wouldn't that have happened somewhere else?
If life has evolved on other worlds, just how many alien civilizations are out there that we could potentially contact? Astronomer Frank Drake developed an equation to help answer this crucial question.
The Drake equation is a really admirable attempt to apply some quantitative reasoning to the probability or the possibility that there is life beyond the Earth.
You multiply the star formation rate for stars in our galaxy times the number of planets that each star has, times the probability that you would have life forming on that planet, times the probability that that life form becomes intelligent. And they estimated that there were about 10,000 intelligent civilizations within our galaxy.
Since the Drake equation was first proposed, our understanding of the galaxy has radically transformed. We have now discovered worlds outside our solar system. Exoplanets.
Exoplanets are being discovered all over the place. There are about 4,000 of them now known, and techniques are finding more every day.
Scientists believe what we've found is the tip of the iceberg. So, if the cosmos is so good at making planets, perhaps it can produce the conditions to make life throughout the universe.
When the Drake equation was devised all those decades ago, we didn't know that exoplanets existed. And now we think that there are quite literally more planets than there are stars in the universe. So even if life is really rare, there are an enormous number of chances for it to take hold in the universe. And for this reason, it is very likely that there is life relatively abundant in the universe, including an uncountable number of advanced alien civilizations. This isn't science fiction, it's just basic probability.
Probabilities suggest a multitude of alien civilizations are out there. So, isn't it a little strange we haven't made first contact?
I think there's every reason to believe that there are civilizations out there, but we have no evidence of them yet. Why haven't we found other civilizations out there?
One answer could be the sheer vastness of the cosmos.
Look at all these lights out here over this cityscape. You could think of these lights as like stars in the galaxy. Now, if there's 10,000 communicating civilizations out there in the galaxy, you might think, oh man, look, there's one right there, right down the street. The problem is, there are hundreds of billions of stars in the galaxy, which means that maybe our nearest neighbor that we can communicate with is not right there, but way across the city.
We live in the suburbs of the Milky Way, 75,000 light years from the furthest edge. Radio signals travel at the speed of light. This speed limit means that any signal sent to the opposite side of the galaxy would take 75,000 years to reach its destination.
The thing you have to remember is the galaxy is gigantic. Even if there are 10,000 civilizations in the galaxy, it's possible that the distances between stars are just so huge that we're never going to be able to communicate with each other.
So, the 45-year-old Arecibo radio message could still be tens of thousands of years away from any potential alien civilization.
The target was 25,000 light years from here. The message is now 45 light years from here because it's traveling speed of light, so it's really far from the target.
The vast size of the universe is a huge roadblock to making first contact, and the laws of physics prevent radio signals from overcoming it.
You just cannot go faster than the speed of light. So our galaxy may be filled with life, filled with civilizations, but they're so far away.
I don't want to be the bearer of bad news, but the universe is just really, really far too large.
The universe may be large, but we're putting the most advanced technology on Earth into action to try and speed up the search.
There really is a serious, scientifically valid way to go looking for other civilizations. And the Breakthrough Listen project is really the best thing we have right now. State-of-the-art facilities around the world, radio telescopes, optical telescopes as well, are all looking up to the sky together.
Breakthrough Listen is targeting the 1 million stars and 100 galaxies closest to Earth. It is the most comprehensive search for alien communications ever undertaken.
If there was an aircraft giving off a radar signal, and that aircraft was around any of the 1,000 nearest stars, the Breakthrough Listen project could hear that. So if there's something out there that's actually giving off a signal, Breakthrough Listen has a chance to find it.
Breakthrough has started by listening in on the nearest 1,700 stars to Earth. So far, silence.
This is the wonderfully, beautifully frustrating position that we find ourselves in. We haven't heard anything yet. So we're in this position where a negative result doesn't mean there aren't civilizations, but we have no proof that there are.
Breakthrough Listen is just beginning its hunt. There's much more real estate in the cosmos for it to search. It's a big job, demanding a lot of patience.
If you go through Drake's equation and find this number of 10,000 intelligent civilizations out there, there are something like 250 billion stars in the galaxy. So that's only one civilization per 25 million stars. That's a lot of cold calling.
The size of our universe means we could be waiting a very long time to pick up any alien communication. But even if we pick up a signal, it may have arrived too late.
If we do receive a message, given that it probably took years to get here, that civilization could be long gone.
So, are we simply too late? Have any aliens out there already died out? Earth has orbited the Sun for over 4.5 billion years. Time enough for humankind to evolve into an intelligent and technologically advanced species. But compared to the age of the universe, planet Earth is just a kid.
The Earth is over 4.5 billion years old, and we think it's taken this long to create the first technological civilization, us. There are star systems out there much older than we are. The universe is 13.8 billion years old.
We tend to think we're hot stuff, right? We're technologically capable, we can build rockets and we can listen to radio waves. But a typical other intelligent advanced civilization would be literally millions of years ahead of us in technology.
So if an alien society has been around longer than us, how much more technologically advanced could they be? One method of measuring just how much is provided by the Kardashev scale.
The Kardashev scale classifies potential alien civilizations into 3 types based on the amount of energy that they're able to harness from their local environment. A Type 1 civilization can harness the energy of only its home planet. A Type 2 could hypothetically harness the energy of its own solar system. And a Type 3 could harness the energy potentially of an entire galaxy.
If you're wondering where we fit on that scale, prepare for some bad news.
We're somewhere between a 0 and a 1. We can't use all of Earth's resources, so we're at about a 0.7.
An advanced species reaching Kardashev level 2 or even 3 could create highly advanced structures that can harness the power of a star.
If you get to be an advanced enough civilization, eventually, if your energy demands are so huge, you might build solar panels that you have enveloped your star. This was first thought of by Freeman Dyson, and so we call these Dyson spheres.
If such epic engineering occurs in other star systems, or even other galaxies, could we pick up some evidence and then make first contact?
The thing about a Dyson sphere is that you've completely blocked all the light coming out from a star, except for the infrared, because these panels are absorbing that sunlight and warming up. When you warm up an object, it gives off what's called thermal infrared light. You can scan the skies looking for that signature to see if there are any Dyson spheres out there.
2015. NASA's Wide Field Infrared Survey Explorer scanned 100,000 nearby galaxies to locate advanced Kardashev civilizations by observing infrared light leaking away from Dyson spheres. They detected nothing.
No such galaxy was found, so they didn't find any infrared smoking gun.
Given our universe is so old, surely other civilizations should have had time to evolve. If so, maybe we've simply missed them.
It's entirely possible that civilizations arose, tried to communicate with the galaxy around them, and the problem was they were asking too early for us. They're trying to knock on our door, but our house wasn't built yet.
Earth has been around for under 1/3 of the universe's 13.8 billion year lifespan. The human race, just 300,000 years. A relatively tiny window of opportunity to make first contact.
We've been looking at the sky for tens of years, something like that. What is the likelihood that at that exact moment, someone is going to be beaming a signal toward us?
Perhaps the universe prevents intelligent civilizations from surviving for very long, making our chances for first contact even more unlikely.
Maybe there is something out there that is filtering us from seeing them. We actually call this the Great Filter. Maybe there is something that says, yeah, you're not getting past here.
Rocky planets like ours are ideal for hosting life, but they're fragile. And this fragility means the universe could filter out intelligent life quickly.
We've discovered very violent star explosions like gamma ray bursts. And these are powerful enough, they may sterilize planets, even across an entire galaxy.
And even if intelligent species survive natural phenomenon, they may still be filtered out by hitting the self-destruct button.
as we can tell from our own experience, the moment that we started developing technology, we also developed the means for our own destruction by changing the climate on our planet, by developing weapons of mass destruction. And so it's quite possible that civilizations that are advanced enough are short-lived. And if they are short-lived, that would explain why at this point in time there are very few of them that might be around to communicate with us.
Finding the relics of an extinct alien civilization could be the ultimate cosmic warning for the human race.
If we were to find a civilization out there that may have destroyed themselves by pollution or conflict, it would be almost like staring into a mirror, and it would be a very grim foreshadowing and maybe a lessons learned for us humans here on Earth.
We can only hope that some advanced alien species escaped the universe's deadly filter. But even if ET still exists out there, the odds are still stacked against first contact.
One other way that we've got this alien contact story a bit wrong is just down to the laws of physics.
Every day, the physics of the cosmos makes our chances of contact worse because our universe is expanding, and it's expanding fast. February 2018. Astrophysicists at the University of Oklahoma find a potential series of rogue planets 3.8 billion light-years away. Ranging between the size of our moon and Jupiter, these would be the first alien worlds ever discovered outside our galaxy. And maybe the first of many.
Our galaxy alone has trillions of planets. The observable universe has trillions of galaxies. It's estimated about 2 trillion. So trillions of trillions? Come on.
But finding exoplanets is no guarantee of finding alien life. And when it comes to contacting extraterrestrials, our efforts have met with silence.
Our search for life has come up empty. Do we need to change our tactics? Are we doing something wrong?
I think it's going to be very, very hard to find extraterrestrial intelligence the way that we're looking for it. We would have to get really, really lucky. But I don't think we're going to get lucky. I think that if we want to know whether there's life out there in the cosmos, we have to go visit it.
We've sent the New Horizons probe billions of miles across the solar system to Pluto. Perhaps one day we'll be able to send spacecraft across the universe to search for alien life on distant rogue planets. But if a craft left our galaxy to visit these new worlds, its mission would be tough, thanks to the physics of the cosmos.
From our perspective here in the Milky Way, every galaxy is on average receding away from us. It looks like nobody likes us and is trying to get as far away from us as possible.
This is because our giant universe is expanding.
When we talk about the expanding universe, we don't mean that galaxies are doing something active to run away from one another. Actually, it's the underlying space that's expanding, and the galaxies are embedded in that, and that's what causes everything to move apart from everything else.
The regions of the universe within 3 million light-years of us are expanding at around 45 miles a second. That's over 160,000 miles an hour.
So with our current technology, do we have any chance of actually seeing what these other planets are like? Well, think about the fastest and farthest things we have right now, like the Voyager spacecraft. They've been in space for more than 30 years, going incredibly fast, 38,000 miles an hour.
38,000 miles an hour is fast. But the closest galaxies to us are moving away at over 4 times that speed. And the further away a probe is sent to travel, the tougher its task.
The thing about the expansion of the universe is that the farther away something is, the faster it's moving away from you.
The more distant two objects are away from each other, the more space there is between them. And the more space there is between them, the more space there is to expand.
The rate at which they're moving away is proportional to their distance. If it's twice as far away, it moves away twice as fast. If it's 3 times farther away, it moves away 3 times as fast.
Scale it up to the planets we've discovered 3.8 billion light years away, and thanks to the expansion of the universe, those extragalactic worlds are moving away from us at over 49,000 miles per second.
Imagine that you're a runner and you see the finish line. You're getting a bit closer to it. But now actually the track itself is expanding. And as the track expands faster and faster, it's expanding faster than you can possibly run. All of a sudden that finish line starts receding and you're never, ever going to reach it.
Say one day we're able to build probes that travel at the fastest speed physics allows, the speed of light. Even that might not be enough, because sometimes the universe itself doesn't play by the rules.
It's not possible for things to travel through space faster than the speed of light, but it is possible for space to expand faster than the speed of light.
Everywhere we look, we see very distant galaxies that are apparently receding or moving away from Earth at greater than the speed of light.
There are distant galaxies we can see in the sky that even if we were to build the most advanced spaceship possible that could even move at the speed of light, we could never get there. 97% of the galaxies that we can see in the distant sky are actually unreachable to us.
So, for all the galaxies out there and all the planets that could harbor life, most of them are out of our reach. The physics of the universe has dealt an immense blow to first contact.
The true reality of the universe will always be hidden from us because of this expansion.
The further we look out into the universe, the more unlikely first contact becomes. We might need an advanced alien race to come and visit us instead. Suppose we get that lucky. Even then, would first contact actually be feasible?
We think aliens are like us. They're not. We're assuming that the life is like us and that their planetary environment is like ours. I don't think that's going to be the case for most of the life in the universe.
So, could extraterrestrials even survive first contact with us and our planet? July 2019. The test satellite discovered a new alien world 31 light years from us, named GJ357d. At over 6 times the mass of our home planet, it's thought to be a super-Earth. And from our observations, super-Earths appear to be prime real estate.
What we see is that the most common type of terrestrial planet is what we call a super-Earth. So that means it's a terrestrial planet, but much more massive.
More massive can mean more gravity, creating a planetary environment completely unlike our own, and life completely unlike ours.
If they're on the surface of a super-Earth, it could be that gravity is going to be way stronger. So these aliens aren't going to be very tall, but they are going to be very strong.
Super-Earths are just one of the many avenues the universe creates. There are other exoplanets orbiting red stars 10 times smaller than our sun, and others making binary systems comprising 2 stars instead of 1.
We see planets of all shapes and sizes around stars of all shapes and sizes of all sorts of configurations. The potential for life is much more rich and varied than we ever thought before.
Retro rockets, 5, and 6, fire.
Images of science fiction have fueled numerous fantasies of first contact, but our knowledge of the universe suggests reality could be far, far stranger.
If anything, Hollywood has kind of constrained our imagination in terms of presenting so many aliens that basically look like, you know, humans wearing a rubber suit or something.
Lower landing legs.
We have to let go of this obsession that they're going to be anything like us. So if we're looking for two-legged dudes, forget it.
Say an intelligent alien species lives in our stellar neighborhood and wants to make first contact with us. If that alien evolved on a super-Earth or orbited a red star instead of a yellow one, its wildly different biology may prevent it from ever setting foot or tentacle on planet Earth.
When you look at life here on Earth, it's almost as if it was custom made for this temperature, for these elements, for this environment. An exoplanet with conditions to support life could still be completely different than life here on Earth.
What are things going to be like on an alien world which has a little bit more potassium, or is warmer than average on Earth, or has a thicker atmosphere? Each one of these small variations can mean a completely different ecosystem.
So could an alien organism really adapt to our ecosystem when it lands on Earth? Maybe we haven't made first contact because they can't actually visit us.
They could step through the airlock of their spaceship and onto the Earth and just find something toxic with our environment, some reason they're not compatible with the surface of the Earth. It's almost as if the universe is out there deliberately trying to stop us meeting any aliens.
Biology creates another obstacle for making first contact. But as planetary scientist Janie Radebaugh finds, even life on Earth can get pretty weird, taking extreme measures to adapt to a potentially hostile environment.
This is the Great Salt Lake. It is the remains of what used to be a much larger lake in the past. And when it evaporated away, it left behind all of the salt.
The Great Salt Lake is nearly 10 times saltier than Earth's oceans. The extreme salt content should make it an inhospitable place for life. Despite this, there are organisms thriving in the water.
As we look at life in this vast lake and find that there are billions of microbes living here in this unexpected environment, then we start to realize, well, life forms in ways that we just don't expect, in places we don't expect.
Microbial life, known as extremophiles, have developed an ingenious way to survive in the lake.
They actually use these solar-powered pumps to pull the salt out of their cells so that they can operate more normally. But in order to do that, they have to live very close to the surface, which means they get a huge amount of UV radiation. So all this pink color that you see behind me is actually the pink of the organisms, and it's sort of like a built-in sunscreen that helps protect them against the UV radiation.
Extremophiles are rewriting our expectations of where life can survive on Earth. Could alien biology be much more resilient than we think?
These extremophiles should be a little reminder that we haven't been thinking big enough.
Maybe ET could readily adapt to our environment. Or perhaps they've got other ideas, using technology to overcome any biological barriers.
Maybe the first aliens we meet will be robots.
They can build much more powerful life if they don't limit themselves to meat bags.
Advanced aliens could have left their biological brains and bodies behind, traveling instead as mobile, artificial intelligence.
We tend to think of intelligence and consciousness as something mysterious that can only exist inside of biological organisms like us, and somehow therefore can't be copied. But what's given us the whole AI revolution, right? The idea that no, intelligence and probably consciousness too is just information processing, and it's just the information processing that really matters.
Perhaps an alien would be able to download its consciousness into some sort of computer and travel as a disembodied consciousness. In this state, you'd be essentially immortal.
So it's possible an advanced species could find ways to face the challenges of first contact. But if an alien civilization is out there and more advanced than us, could there be an even bigger issue at play?
Maybe the reason that intelligent aliens haven't ever come to the Earth to visit us is maybe we're just not that interesting.
So maybe the biggest barrier for first contact is the fact that aliens don't actually want to meet us. In the movies, first contact usually leads to an alien invasion. Cities get zapped. Humanity faces annihilation. Maybe a visit from ET isn't such a good thing after all.
Imagine if we got an intergalactic email from, superioraliencivilization.org saying, hey, we're gonna show up in 30 years. Would we just be like, oh, well, let's get back to watching our reality TV shows and worry about that when they get here? No, we would seriously freak out.
People might freak out. But the truth is, we've been signposting our location into the cosmos for decades.
The Earth has been a detectably technological world for about 100 years. We've been broadcasting signals. And yet, that apparently hasn't attracted anyone's attention.
It's pretty noteworthy that none of them has shown any interest when they could have turned Earth into a parking lot if they wanted, right?
Perhaps no one has redeveloped planet Earth because an advanced civilization simply doesn't want to make first contact.
Frankly, if they're that intelligent, they're not going to be very interested in us. So maybe that's why they haven't bothered to make contact.
And if the alien is that advanced, we're probably not very interesting to it. It's a little bit like, wandering around outside and seeing ants on the sidewalk.
Alien invasion makes for great science fiction, but what do we actually have on Earth that's worth all that alien effort?
How realistic really are these depictions from Hollywood? One common trope is for the aliens coming to devour the human race. But the science doesn't really support this being possible. Would an alien even be able to digest the human body?
When eating, enzymes in our digestive system break down molecules in our food. The food we can eat and these enzymes are very specific to the molecules they can attack and break down. The same rules would apply to a hungry alien.
To be able to digest us and for us to be nutritious for them, we'd have to have a very, very similar biochemistry to what exists on the aliens' homeworld, what their bodies have adapted to.
So it seems highly unlikely that aliens would come looking for food. But how about a drink?
In order for life as we know it to exist, one needs liquid water.
If aliens live on a barren desert planet, a water world like ours could be highly attractive. While we call ourselves the blue planet, our oceans are not unique. The universe offers far greater water resources.
In our solar system, we're finding that most of the liquid water exists in moons around the gas giants.
We believe Jupiter's moon, Europa, has a layer of water ice around 15 miles thick, floating on an ocean up to 100 miles deep. This single moon may have twice as much water as all Earth's oceans combined.
Europa is the water world of our solar system and not the Earth. So if you were an alien looking for water, you wouldn't bother going to a big planet like the Earth to suck it up through some kind of giant straw. You'd go to the outer solar system. You might harvest icy moons.
Instead of working against the powerful gravitational pull of Earth, an alien race could draw water from Europa, where gravity is almost 10 times weaker. So, what other resources have we got to offer?
Maybe aliens come to strip mine the Earth's crust for metals, iron or titanium or platinum. Aliens might use these metals for exactly the same things that we do, for building spaceships, for building their technology.
Such materials could be useful for any alien civilization short on mineral resources. Problem is, a lot of our planet's metals are buried deep in the Earth's interior.
When the Earth formed, the great deal of its iron sunk down into the core of our planet and took a lot of metals with it, so they're actually quite hard to mine on the Earth.
An alien race would be better off prospecting for more accessible minerals situated in the asteroid belt.
In the asteroid belt, there's an asteroid called Psyche, which is made up of pure iron nickel, just like the core of the Earth.
Psyche provides a near 150-mile exposed strip of iron nickel. Yet another reason ET wouldn't need to bother with us.
For my money, none of those reasons will draw aliens to our Earth. All these things can be found far more easily elsewhere.
The possibility of first contact is beginning to sound increasingly remote. The universe throws up massive barriers stopping us from communicating with an intelligent alien race. A race that might very well have absolutely no interest in contacting us. Unless, of course, they already have.
Is it possible that there have been alien signals that we've already detected, but we didn't realize what they are?
Scientists have discovered a powerful cosmic signal that they cannot explain. Could this finally be first contact? July 2018. The Chime telescope in British Columbia detected a short flash of radio energy, quicker than a blinking eye. It's called a fast radio burst.
These are intensely powerful, very, very short-lived radio bursts that can be 1,000 times brighter than the sun at radio wavelengths that arrive and disappear in an instant.
Most fast radio bursts are one-offs, blinking into existence, then disappearing forever. But not this one. A few days later, scientists caught the flash again.
The amount of energy that it takes to produce a burst like this, for us to detect it here on Earth from billions of light years, is immense. And we've run across things like this before. Exploding stars, gamma ray bursts. These are all very strange objects. But that does not explain these because some of these fast radio bursts repeat. So whatever it is that can generate this kind of energy, it can do it more than once.
Light comes in many different wavelengths. Radio waves are the longest, making them good for long-distance communication. We've used radio waves for over 100 years, from wireless radio to TV. From cell phone calls to communications with space probes. Could alien civilizations be using radio waves, but on a much larger scale?
What if we already intercepted alien communications, but we just don't know it?
Our radio and television signals only use a very narrow band of the radio spectrum. Fast radio bursts are different, and that's a problem.
Here's the thing about fast radio bursts. They are emitting a broad range of wavelengths, so it's not the best way to communicate. If these are aliens, they're not very smart aliens.
It turns out that broad-range wavelengths are easy to distort.
There is a very thin gas out there between the stars. And when you emit radio waves, the radio waves interact with this gas. And the way they interact depends on the wavelength you're talking about. If you use a broad range of wavelengths to send a signal across interstellar space, by the time somebody receives it, it can be a little distorted and weird.
If aliens are sending out radio bursts, the signal would get so degraded that by the time it reaches us, we wouldn't be able to decipher it.
As a calling card, not incredibly useful.
Whether these mysterious bursts really are aliens trying to say hello or just a natural phenomenon, this is not first contact. At least, not yet.
I want to be careful here, right? I'm not a naysayer. I'm not going to poo-poo aliens. But, let's go through the other things first, because the universe is filled with weird stuff, and let's see what that is. And if we eliminate all those, and all that's left is aliens, yeah, let's talk.
If extraterrestrial species are out there, our universe makes it extremely difficult to contact them. But in spite of all the obstacles, maybe there's still hope. We once thought that there could be 10,000 intelligent civilizations in the Milky Way alone. Now, we know that our cosmos is filled with planets just waiting to be found. Our technology is evolving. Searches are expanding. The truth about our mission to make first contact is this: we are only just getting started.
I'd love for tomorrow morning some sort of interstellar tweet to be beamed at the Earth, and we would then realize that we are not alone in this cosmos.
I'm ready to celebrate. Here we have already a champagne on ice to pop when they find it.
Scientists really do hope we find evidence of extraterrestrial life someday. We have observatories and satellites that look at the sky all day, all night, every day.
The discovery of alien life would simultaneously be, in a way, unsurprising, and yet the greatest discovery in all of human history. Even if life is really, really rare, the universe is really, really big, and so there could be countless alien civilizations out there. But the actual discovery or confirmation of that, I can think of no greater scientific discovery. It would quite literally change our entire civilization.